everyone, welcome again. In the last video, we covered how to build cloud native apps using Spring Cloud projects. Moving in the same direction, in this video, we will now cover the basics of cloud. So let's kick off. Before we understand the cloud, we need to spend some time on the traditional computing. Suppose we have a personal laptop or a personal desktop, and in the same way, an organization has its own data centers. And when the time comes to have more computing power, what do we generally do? In case of personal laptop or personal desktop, we buy more hardware. So for instance, if my personal laptop has a RAM of 4 gigabytes and I need to upgrade it, then I would buy a new RAM of, let's say, 16 gigabytes. And in the same way, let's say the organization is facing some performance issues, or maybe they are onboarding a new client environment. So to do that, they need more computing power, they need more resources. And what are their options? They may add more resources to their existing data centers, or they may even decide to set up a new data center. So what do? We upgrade the systems to get the better machine. We buy more hardware, newer machines to upgrade the computing power, and we are responsible for it. So if I own my personal laptop, I am responsible for its security, for its upgrades, whether it is software updates or patches and all those things. And in the same way, an organization is responsible for its own data centers. So in traditional computing, an organization is responsible for the data centers, maintenance of those data centers. That includes all sort of things like physical security, including the staff and security personals, electricity bills, cooling, managing the hardware, acquiring new machines whenever we need it. When it comes to the software, so the organization is responsible for softwares, operating systems, licenses, updates, patches, basically everything that is required to keep things up and running. All right. So what is the problem with this? If it has been like this, and if it has been working like this, it's not that it's inherently bad or bad things are going to happen if we keep managing our own data centers. But the thing is, same as many other technologies, many other frameworks or practices in the software development, this model is a bit outdated. It's not that efficient anymore, considering how the business is changing, how the market is changing. So here we will discuss some of the key problems with the traditional computing. Let's start with the slow onboarding. What that means, let's say an organization is planning to onboard a set of new clients. Now it's not as easy as it sounds, because a lot of effort goes before we can onboard new clients, before we can set up new environments. So it requires a lot of analysis, a lot of agreements. We need to identify the usage patterns. We need to identify or do the estimations for the capacity or the computing resources that we would need. And let's say if we don't have the reserved capacity, then we may need to upgrade the data centers. We may need to buy more machines, more RAM, more virtual machines, and all that stuff. So in general, this kind of onboarding is relatively slower with the traditional computing model, depending on the health and state of the data center. And that leads us to the second point, which is planning in advance. Because arranging resources or buying hardware on a scale is not easy, it takes time. So to compensate that, organizations plan these things way more in advance. So that means if an urgent requirement comes and urgent onboarding comes, then they cannot handle it. They have to stall it, because that would disturb the current estimation and they'll now have to manage more resources. And that also means that they have to think about some kind of reserved resources, even if they are not required right now, but they still have to invest in it. So these are kind of underused resources because they are there, but nobody is using them. The third thing is time to market. So let's say a team is working on a new technology or a new framework or a new problem domain that requires some sort of special setup in terms of hardware or resources. And if that organization does not have that kind of resource, then it takes time again to set up or to have that kind of setup to support the development or POCs or everything. So that's directly impacts the time to market, because you need to wait for the setup before you can start the development or the analysis. That would obviously slow down your delivery. And the last and probably the most critical factor is the cost. In this model, the organization is responsible for everything. So they are paying for the data centers, they are paying for the employees who are managing those data centers, they are paying for the security, basically everything to support the data center. And whatever resources they manage in those data centers, they have to pay for them even if they are not used anymore. So let's say you anticipated a new client onboarding, and to support that you arranged some sort of computing resources, you invested in those resources. But let's say the deal got off for whatever reason, and now you have to pay for those resources. So there is always this cost factor associated with all those things in the traditional computing model. Alright, now with this context in mind, let's see what cloud is and how it changes everything. While cloud ecosystem is too huge considering different vendors, their different offerings, different solutions, but it all comes down to a simple thing that cloud computing is about delivery of computing resources over the internet. And what are these computing resources or computing services? Well, it could be a virtual machine, it could be containers, databases, networking components, or storage. Earlier, it was the responsibility of an organization. The organization was responsible for the data centers and all the computing services. But cloud changes everything. It makes the delivery of these services easy. You need a new virtual machine, you can get it quickly. You don't need to manage the resources. You simply need to make a call. It could be a call from the front end, it could be a call from the command line utility, or maybe simply an API call, and that's it. You get the resources way more quickly with cloud computing, and it changes everything. Talking about the key characteristics, the first one is definitely going to be that you get the computing resources on demand. We don't need to plan way more in advance. Whenever we need a resource, we can get it in minutes. The second benefit is we get the benefit of resource pooling. So because the cloud vendor is responsible for arranging all those hardware resources, and because they manage all these things on a very huge scale, they get special benefit or discounts from the manufacturers. And all those savings are propagated to the customers as well. So we get the benefit of that resource pooling. And as we talked about earlier on the previous slide, that it's about delivery of computing services over the internet. So cloud vendors expose their services or different offerings as a service. So everything, almost everything is exposed as a service. And you may have heard about it: function as a service, backend as a service, container as a service, platform as a service. So everything is exposed as a service, and we can simply utilize it. And the last one, and probably the biggest reason why organizations are thinking to go cloud, is their pay as you go model. So you don't need to spend a big cost, a big amount upfront, but same as an electricity meter, you pay for what you use. Chances are, let's say for a resource, if you're not using a resource, you don't have to pay for it. And even if you do, maybe a fraction of that money. It just depends on the service that you are using and the cloud vendor and its billing model. But in general, it's pay as you go. Let's move on and understand different service types. As we covered, that cloud vendor expose almost everything as a service. So we have different functionalities exposed as a service. But these three listed here are fundamental service types. So we have infrastructure as a service, platform as a service, and software as a service. This is probably one of the most important things to understand, because when we move from on-premises to cloud, we lose control, some sort of control. And a particular service type clearly defines the responsibility. That is what is owned by the cloud vendor and what is owned by the customer or us. That leads to the shared responsibility model. And here we will understand what is the meaning of IaaS, PaaS, and SaaS. That means infrastructure as a service, platform as a service, and software as a service. This is called shared responsibility model because it clearly shows the segregation of responsibilities between the customer and the cloud vendor. So for example, if we talk about the on-premises, when we have the data centers on-premises, when we own the data center, then it is the responsibility of customer or the client. So the client is responsible for everything, starting from the physical security to the physical machines or the physical resources, the software, the application, the configuration, access control. Basically everything is owned by the client. When we move to the cloud, and let's say if we adopted IaaS, in that case we get the infrastructure as a service provided by the cloud vendor. And in this case, the cloud vendor or the cloud provider is responsible for the data center, the physical security, the infrastructure. That means the virtual machines or any hardware. But everything else is owned by the client or the customer. So that means we will get the virtual machine, for example, but the client is responsible for installing the operating systems or any required software. The client is responsible for the software updates, patches, security patches, the application, the storage, basically everything. We just get the hardware or the infrastructure from the cloud vendor. So infrastructure as a service provides the highest degree of control to the client, which is possible. But that also means that we have more responsibility with us. Coming to the PaaS, which is platform as a service, when we choose platform as a service, we lose more control because now we don't own the operating systems or any required softwares. We basically own the application, but everything else is managed by the cloud vendor. So that means if I have to run a Java application and if I choose a PaaS solution, then that means I don't have to worry about the JDK or JRE or let's say Tomcat. I just need to provide my executable, that is jar file or var file, and the platform would take care of it. It would run my jar or my executable so that I can run my application. But as you can see, the client or the customer is partially responsible for the data storage and access controls. That means even if the cloud vendor will take care of some sort of security, encryption, decryption, and everything, but how we secure our application is still lies with us. So that is the responsibility of the client. And again, the application configuration, because application is owned by us, how we deploy, how we configure this application is owned by the client. And the last category here is SaaS, which is software as a service. In software as a service, everything, almost everything is owned by the cloud vendor. We get the application, we simply use the application, but we are partially responsible for the access controls, identity, and the configuration. So for instance, Gmail would be a perfect example of a SaaS solution. So in case of Gmail, we don't own the application. We don't need to think about its availability, how it's deployed, how it's secured, and everything. It's all taken care of by Google. We simply use the application, but still we are responsible to make sure that the Gmail account is secure. We don't share the credentials, it's up to us. And the configuration, that means every user has its own preferences and they can change, let's say, their privacy settings and everything. So in SaaS solution, we use the software directly, but we are partially responsible for identity and access controls, and of course the configuration. So that is the basic difference between infrastructure as a service, platform as a service, SaaS, and on-premises. It's about how much you want to control or how much you want cloud vendor to control and manage, so that you can simply focus on the business domain or the problem domain or just the application development. So it's basically a trade-off. All right, moving on. Let's talk about the cloud models. There are 4 typical cloud models: private cloud, public cloud, hybrid cloud, and multi-cloud. Starting with the private cloud, what is a private cloud? When the cloud infrastructure or a segment of a cloud infrastructure is reserved for a particular client, that means the underlying resources are not shared among other parties. Nobody can access those resources. So that instance is secured and reserved for a client, and that is called as a private cloud. The location does not matter in this case, no matter if it is on-prem or on the cloud, but as long as it's private to that client, it's called a private cloud. The second is public cloud. Public cloud is what we generally use. In public cloud, we get all the benefits of cloud infrastructure, but the thing is, here the infrastructure is shared among different clients or different tenants. What that means is, let's say in a data center, there is a rack, and in rack, there are n number of machines. And one of those machines is running n number of virtual machines. And let's say that machine is capable of running 10 virtual machines, and I need only 2. So 2 virtual machines will be allocated to me, which are running on this physical machine. And a second client comes and he needs 3 virtual machines. So 3 virtual machines will be allocated to a second client, but those 3 virtual machines are also running on the same hardware. So the underlying resources are shared. There is this isolation, but the underlying infrastructure is shared. That is the purpose of, or that is the meaning of public cloud. Coming to the hybrid cloud is a mixture of on-premises and cloud infrastructure. So an organization may choose to keep some things on premises, probably due to compliance or regulatory reasons or security reasons, but they may choose to move other stuff to cloud, and it will still work. They can still work with on-premises and cloud. That is the power of hybrid cloud. So in hybrid cloud model, you have some things running on on-premises data centers while other things are running on cloud instance. And the last one is multi-cloud. Multi-cloud means multiple cloud providers are involved. So let's say an organization is running a certain workload on Azure cloud, but some other things are running on AWS. So here we are using 2 different cloud offerings, AWS from Amazon and Azure from Microsoft. So that is multi-cloud. Now that we have covered quite a few about cloud offerings and cloud in general, we can finally talk about the benefits. When we move to cloud, we get the benefit of high availability. What high availability means that your application is available, your infrastructure is available, because in case of cloud, The cloud vendor is responsible for making sure that infrastructure is always available. So there is always some kind of redundancy involved, backups involved. And in case, let's say, a machine goes down or a rack goes down, they can always get the backup up and running in no time. And in some cases, there is actually zero downtime. So in general, we get the high availability, which is generally not possible if we are owning or managing the resources. And that leads to the second point, which is scaling. Scalability is the ability to scale to meet the demands, and which is super easy with cloud. So let's say if we are running a virtual machine and we have to upgrade it, we have to add more memory, or we have to upgrade the computing power, then with cloud it's super easy. We can simply upgrade the existing machine, or we can get a new machine with more power in minutes. And similarly, we can add more instances. If we have to scale out, we can set up automated scaling rules so that whenever, let's say, a threshold reaches, the infrastructure would automatically scale out the instances. It will add more instances. And when the demand goes down, it can automatically scale in. So cloud makes this scaling super easy, and it makes the applications elastic. Next is the reliability. Because of the high availability and easy scaling, we get the reliability out of the box. There are automated backups. We can deploy the applications in different regions altogether, in different zones. We can easily set up the backups, the sharding, the partitioning. So that makes sure that we don't lose the data, that application is always up and running, and it is doing the right thing. And in the same way, we get monitoring out of the box. Because of the highly distributed nature of the cloud, where machines can fail anytime, where racks can go down anytime, since everything is over the internet, so we may face networking issues or the latency. So how do we make sure that everything is up and running, and if anything goes down, we can identify it as soon as possible? For that, we have monitoring in place. And that is done by the cloud vendor. They have extensive monitoring. They monitor all aspects of the infrastructure, whether it is hardware, networking, resources, storage, everything, so that they can keep track of what's going on in the system. And if there is a problem, they can quickly identify it in order to fix it. And so we get the same monitoring support when we move our workload to cloud. And that leads to the next point, which is related to the performance and good user experience. So consider this: when your application is highly available and it is elastic, that means it can scale out or scale in depending on the demand, and it is reliable, that means data is always up to date, it's always available, and you have extensive monitoring in place, then you of course get a good performance, and that ultimately results in a good user experience, because users are not frustrated in case there is a huge demand at that point of time, because cloud infrastructure and the rules that you have set up would scale your applications out. They would add more instances to handle more demand. So we ultimately get a good user experience out of it. And the last and probably the most important aspect is cost effectiveness. We are not investing upfront and a big amount in data centers, in machines. We have delegated this responsibility to the cloud provider. Now we are only paying what we are using. We are monitoring. We can set up the cost alerts, the budgets. If we arrange more virtual machines and let's say the demand goes down, then we don't need to keep them running. We can simply reduce it, destroy it. And that saves the money for the organizations, which is way more cost effective than running your own data center. So that's pretty much it on the basics of cloud computing. We covered what is the traditional computing, what are the challenges with traditional computing, what is cloud and how it changes things, how it forces us to think with a different mindset. Hope you like this video. See you in the next lecture. Thanks for watching.